Hello everyone. Today we're going to show you the demo of Aptomi. Aptomi is a policy mesh that allows teams in your organization to define their services and microservices, offer them in a controllable way to the rest of the organization, and have global operational rules and governance policies around that. More information on that can be found in a separate Aptomi overview video. Now let's talk about the Aptomi object model. Aptomi model is very simple but very powerful. It's built around the concept of a service, and services can be defined and offered through Aptomi, and services can be consumed as well. Also, there is a notion of the context. Context defines who the service is for and how resources get allocated. So for example, you can have separate contexts for production and staging, or you can have separate contexts for, let's say, important consumers or consumers that are not that important. Also, you can feed global rules into the system. For example, you can define a rule saying that a developer can never deploy to production cluster. Our demo use case is built around two services. One service is Twitter stats defined by John. This service pulls data from Twitter in real time, calculates hashtag statistics, and displays results on the web. And in order to do this, John's service relies on another service called Analytics Pipeline, defined by Frank. John and Frank offer their services in multiple different contexts. For example, John set up rules in a way that there is one instance of Twitter stats in production, and there's going to be multiple instances of Twitter stats in staging. Every consumer will get its own instance. Frank also offers his Analytics Pipeline service in two different contexts, one for production and another one for stage. And he set up rules in a way that the staging instance is going to be shared by all the consumers. In addition to that, there is Sam, who is the global operator, and he defines the global rules of the land. So the demo is set up in a way that people with different roles interact with Aptomi to publish and define services, to consume services, and also to define the global rules. Aptomi takes all this information together with the user attributes from LDAP to identify service consumers. It evaluates the policy, makes decisions, instantiates services, and configures components in the underlying cloud. It also provides visibility for the ops people into what's going on. So that said, let's go ahead and look at the live demo. Right now we're looking at Aptomi user interface, the screen called Audit Log, which contains all configuration revisions of Aptomi. And right now we're starting from scratch, so no services have been defined in Aptomi yet. And the only thing that Aptomi knows about is two Kubernetes clusters, US East and US West, that we have defined up front. It knows about the users, which are loaded from LDAP, and it knows about three global rules, which we're going to talk about later. So now let's go ahead and add services into Aptomi. This is the GitHub repo where we are going to be making all the changes. And once the change is made, Aptomi will pick it up and apply it. So first of all, let's go ahead and add Analytics Pipeline service into Aptomi on behalf of Frank. So Frank is a service ops guy who defined his service, and Analytics Pipeline is basically a service that embeds HDFS, Kafka, Spark, and Zookeeper under one umbrella to create a data analytics pipeline. So for every service, Frank specified the service definition file, and it's basically just a pointer to the Docker container image and a set of parameters. And in addition to the service definition file, Frank specified two contexts, because Frank offers Analytics Pipeline in two different ways. So one, he offers it for the ops people who control production instance of the analytics pipeline. And for them, Frank says that the service should run in the cluster US East. And also, Frank defined the separate context for developers who are going to share the same instance of the service and stage. And Frank defined a rule saying that for developers, the service should run in the cluster US West. So now let's go ahead and add the service into Aptomi. And in the future, it's going to be done through the API call made by Frank. But right now, for simplicity, we're just going to go ahead and set the enabled flag from false to true. And once we do that, Aptomi will know about the change. And now we can see that the new service definition has been published to Aptomi. And the Aptomi knows about the analytics pipeline service, all its dependencies, and contexts. Now let's go ahead and publish Twitter stat service into Aptomi as well on behalf of John. John defined a Twitter stat service, and John's service relies on Frank's service called analytics pipeline. And also, in addition to the analytics pipeline, it contains components for reading, processing, and visualizing messages from the Twitter stream. John offers Twitter stats in two contexts as well. One for the ops people who control production instance, and in the same way as Frank, this instance is going to run in the cluster US East. But it also offers Twitter stats in stage for developers. And John defined a rule saying that for them, the service will run in the cluster US West, but when they request an instance, every developer will get their own instance of Twitter stats as opposed to sharing the same instance. So we're going to go ahead and import this service in exactly the same way as we did with the analytics pipeline by changing the enabled flag from false to true. And once we commit that change and go back to the Aptomi UI, we will see that the Aptomi knows about that service as well. And if you look at the service graph, you will see that the Aptomi knows about Twitter stat service, which depends on the analytics pipeline. At this point, Aptomi has just service definitions and context definitions, but nothing has been instantiated yet. Now let's have some consumers come and declare dependencies on the services defined by John and Frank. First of all, we are going to let the ops team instantiate the Twitter stat service in production, and we're going to do this by declaring a dependency, saying that the ops team requests an instance of the Twitter stat service with a certain version of the visualization tag, and they also pass down the location from which the tweets should be pulled. For the purposes of this demo, we're going to just go ahead and change the flag. And once we do this, we will see that Aptomi actually starts the deployment process. Here in the console, you can see that it's in the process of creating the required instances. Also, if we go ahead and look into what's happening in Kubernetes, we can see that in the cluster US East, a bunch of containers have just been created. If you look at the graph, you will see that the number of components have been allocated in production by request from the ops team. Twitter stats, Spark, Kafka, HDFS, Analytics Pipeline, as well as Zookeeper. Let's go ahead and declare a couple of more dependencies. This time around, we're going to let developers, Alice and Bob, instantiate Twitter stats as well. So first of all, let's go ahead and do this on behalf of Alice. And the only thing that is different from the Alice's standpoint is that Alice tests a new web application code for visualizing data from Twitter that she has just developed. So she passes a different image tag into that service. Now let's instantiate Twitter stats on behalf of Bob, same way as Alice. He declares a dependency on the Twitter stat service as well, And from Bob's standpoint, let's say he is interested in the tweets coming from Mexico, so he passes the corresponding location as a label into the Twitter stat service. The quick note here is that neither Alice or Bob define the specifics, where the service should run, whether they want to share an instance or not, but Alice and Bob, they just declare their intents, saying that I want to consume this service. And Aptomi makes all allocation decisions for them, so the implementation details are completely abstracted away from the consumer. And the way how service is allocated is controlled by the service owner via contexts. So if we look into Kubernetes, we'll be able to see that the instances for dev have been allocated in the cluster US West. And also, this is reflected in the Aptomi UI. So you will see that a couple of more revisions have been created. Revision number 5 represents the world with the Alice's service. So you will see that for Alice, we allocated another version and another instance of all of those components, but in stage. And then the incremental revision is when Bob declared a dependency on Twitter stats. Now you can see that for Bob, Aptomi didn't allocate any new instances of services other than the Twitter stats in stage, because the rules by the service owners are set up in a way that every consumer they get their own instance of Twitter stats in stage. But for the analytics pipeline, since the service is shared and it's already been allocated, Bob will just use the same instance that has been allocated for Alice. Now let's take a look at what happened exactly. In order to do this, we're going to go and log in into Aptomi as a global admin SAM. And we're going to use the view called Policy Explorer. And when we open the global view, we will be able to see that John requested a dependency on Twitter stats, and this dependency has been fulfilled in the cluster US East. And Alice and Bob, they also requested dependencies on Twitter stats. Those dependencies, they have been fulfilled in the cluster US West by allocating dedicated instance of Twitter stats to Alice and a dedicated instance of Twitter stats to Bob, while sharing the analytics pipeline in the same cluster. Now let's take a look at this from the standpoint of service owner. If I log in as John, I will be able to see that my service Twitter stats has been allocated 3 times. One because of a dependency declared by John, and also 2 times in stage because of dependencies declared by Alice and Bob. Now, if you log in as Frank, the owner of Analytics Pipeline, you will be able to see that Analytics Pipeline has been allocated 2 times. One in the cluster US East because of dependency declared by John, and also once in the cluster US West because of the dependencies declared by Alice and Bob, who are actually sharing the same instance of Analytics Pipeline. So now let's check that all the services have been successfully deployed. So first of all, let's check production version of the Twitter stats. And we're going to do this by clicking at the services endpoint that Aptomi has received from Kubernetes. So we're going to go ahead and open that endpoint, ensuring that production version of Twitter stats is alive. So here you can see that it's successfully pulling data from Twitter in the real time and it's showing it on the web. Now let's go ahead and do the same for Alice's version. This is the Alice's version of Twitter stats, and you can see that the look and feel is a little bit different from production because Alice is testing their own version of the visualization code for showing tweets on the web. Now let's check Bob's instance. So this is Bob's version of the Twitter stats, and because Bob specified Mexico as the location for the tweets, you can see that the hashtags from Mexico are being displayed. Now that we know how Aptomi makes life of the service owners easier, and now that we know the basic concepts, let's show examples of the more advanced functionality. So let's start with the update. As you remember, Alice was testing a new version of the visualization code. So now let's say Alice is happy with her change and her code works as expected, and this change needs to be rolled out to production. So there is no way Alice can deploy to production directly by herself, because Aptomi will actually never allow that because of the global rule that says that the dev can not deploy to production cluster. And Alice is a developer, so she has the appropriate attribute in LDAP, and we can go check out it really quick on our local LDAP instance. We can see that for the Alice, organization is equal to dev. So because Alice cannot deploy to production, she has to ask the ops team who owns the production instance to update it. So Alice gets rid of her instance. And she asks John, the member of the ops team, to promote the new version of the visualization code to production. And John is doing this by just updating the dependency, passing the new tag into the Twitter stat service through the dependency that's been declared. So Aptomi picks this change up, and you can see in the audit log that Alice's version of the Twitter stats got deleted, and the production version of the Twitter stats got updated. We can see that the Alice's service is gone. It's no longer available because she got rid of her development instance. And if you look at production, you will be able to see that the look and feel of production instance has changed to the new visualization code. This basically shows that the service update can be done through Aptomi by changing a single label. Next, let's demonstrate how you can control service consumption through Aptomi. Let's say Carol tries to get her own instance of the Twitter stat service. So she declares a dependency, but nothing is going to be allocated for Carol. The reason that nothing got allocated for Carol is the global rule that Sam has defined. And if you take a look at the global rule is going to say that all the users with the labels team equals to mobile dev were not allowed them to access any services. And if you look at LDAP, Carol actually belongs to the team mobile dev. Also, you can go to the Policy Explorer and actually understand why Carol cannot get a version of the Twitter stat service. You can take a look at the policy evaluation log, and you will be able to see that the global rule applies, and that's why a dependency cannot be fulfilled. Finally, we're going to demonstrate how you can block access to services on the wire through the same mechanism of Aptomi rules. Let's assume that Bob got terminated and he got marked in LDAP as deactivated. If you go back to Aptomi, you will be able to see that there is a rule called deactivated users lose access, meaning that if a user has a label deactivated, then access to his services are going to be blocked. And we can see that this rule is now active and it applies to Bob. And we can verify that by going to the Bob's instance. If we refresh the page, then you can see that the access to this instance was blocked on the wire because of the rule defined in Aptomi. That concludes our first demo of Aptomi. We just showed how Aptomi makes life easier for service operators, allowing them to regulate consumption of their services in a programmatic way. And we also showed quick examples of the global rules, mostly related to access control, but in the real life, one can define much more complicated rules. You can draw boundaries between different environments, you can control resources, performance characteristics, and scaling, and you can control security as well. Thank you for watching.